In Chapter 10, we develop path following control laws for the vehicle. We design these high-level control laws based on the models that we developed in Chapter 9 to allow the UAV to follow straight lines in circular orbits. So in this video, we're going to review the architecture of the book and show a demonstration of what these capabilities will give us. And then in following lectures, we'll develop the straight line following control law as well as the orbit following control law. So let's go ahead and go look at that demo. So what we have here is I've designed a path shown in this green line as a series of waypoints. So the first waypoint was back here, waypoint 2 was right here, waypoint 3, if you see my mouse is right there, and the final waypoint 4 right there. So one thing to note is that the aircraft is at a slightly different height, not too bad, but it's definitely off the path. Remember, each one of these grid squares is 100 meters. So we start off of the path, and our goal here is to just be able to fly along this path. So we'll do that over the next couple chapters, but let's go ahead and take a look. So as I start to go, you see that the aircraft comes to the path, the desired path, and I'm going to actually pause it and show you a couple different things. So first, we have a path segment that we're trying to follow. So that's what we'll develop in Chapter 11, is we'll develop how to manage various path segments given a series of waypoints. So we have the path that we're trying to follow in green, and here we have just this straight line path segment that we are currently following. So we define, start this in, there we go. So the aircraft is able to converge onto that green line. You see that it converges pretty good in terms of both height and the horizontal plane. And it's able to follow that straight line path, but we don't necessarily want to follow it all the way to the next waypoint. And here you'll see in a second. Instead, what we'll do is we'll connect these straight line pieces with circular arcs. And in Chapter 11, again, we'll talk about different options for doing this, but one of the options is to connect the straight lines with circular arcs. And the great thing about that is now it provides a natural motion that allows us to go from one line segment to another. And so the aircraft, instead of just following the line segments, now follows this circular arc until we reach a point where it should start following the line segment again. So those are the capabilities that we're going to be developing in Chapter 10, is how do we follow a straight line and how do we follow an orbit. And then in future chapters, we'll go ahead and get that going. So let's jump into the lecture slides. So again, here's a review of the control architecture that we have ready for us. We are going to be working here in Chapter 10, where we take a path definition. In this case, it'll be either a line or a circle that we want to follow, and then we'll follow that path. Chapter 11, then we'll discuss the path management. How do we decide when we're given a series of waypoints, how do we decide when we're following what straight line, and when do we switch to an orbit? Then in Chapter 11, or Chapter 12, I should say, we actually develop those waypoints. So we go through and we say, hey, here's a series of waypoints to follow. Path Manager produces either a line segment or a circle, and the path follower then follows that line segment or circle. So this slide talks about just why path following. So a major issue is wind, especially for small UAVs. And we have a host of options of things we could do, but two general options are one, we could take, say we're given a path, we could define a point that we want to be at every point in time for the aircraft. So we could associate a time value for each one of these points. And this is known as trajectory tracking. So a trajectory is a path and time, or really a position or a state and time defined along your path. So we just decide what exact state you're going to be in at what exact time. And so that's trajectory following. With wind, where you're going to potentially be blown off of the path, that can cause problems. So we might be at a small error to start off with, but the wind might push us off to where our aircraft is all the way over here. So we have a larger error, and we're trying now to make up to the next point in time, and really it's instantaneous. So we're really trying to push back to that desired value, while that desired value keeps moving out in front of us, right? So at another point in time, we might get pushed even further off, right? And we're really trying to come back to the path all the way. And so as time goes on, we could get further and further away because the wind just doesn't allow us to converge to our desired values or desired trajectory over time. So that's one issue that we need to overcome. Ground robotics often we can do trajectory tracking, but with a UAV where we have that massive disturbance with the wind, that can be problematic. So a better approach for a UAV is just to do path following. So rather than follow a trajectory, we control the UAV to stay on a path. And so we design a path and have the UAV try to execute that path at a given speed. Okay. So, like we showed in the video, there's going to be two different main path types that we focus on. First, we'll focus on straight lines between 2 points in 3D. So the straight lines we follow can have different altitudes. So this will allow the aircraft to change its vertical altitude. And we'll also have circular orbits or arcs in the horizontal plane. And so these circular orbits, we'll just assume that we're flying in a horizontal plane, and we'll try to follow that horizontal trajectory. Not trajectory, path. So, and then as we saw in the video, we'll then stitch these things together to allow us to follow much more complex paths. So these two control laws will be our path following primitives that we'll then build on in future chapters. So there you have it. We're going to be developing these control laws now in the next couple of lectures.